Okay, so there was a minor technical issue there, and I needed to go back and edit something, and yeah, so I ended up stopping this, and we are going to just have to do this as a two-part video. So I want to illustrate what happens just in cases where we use some of these other trig functions and we mix them around like this. So let's say that we want to do something like the sine of the inverse secant of 6. In fact, I probably shouldn't have added that theta already because that's what we're going to do. We're going to call this some angle theta. And what we are going to do here is we're going to do this just like we were doing it when we only had inverse sine and inverse cosine to work with. We're going to just say, let's build a triangle, and we want this triangle to have an angle theta where the secant of theta is equal to 6. Now, the thing is, what is secant? Well, secant is the reciprocal of cosine. But another way of thinking about that is this. We can say that the secant is equal to cosine, remember, is adjacent over hypotenuse. So the reciprocal here would be hypotenuse divided by adjacent. Okay, so what does that mean? Well, that means I want to build a triangle here with an angle theta, and I want to make it so that the hypotenuse divided by the adjacent is equal to 6. How could I label this triangle to do that? So see if you can figure out how to label that triangle to get this property. If you weren't able to figure it out quite yet, here's a hint. This side is the hypotenuse. For some reason, I'm having a lot of trouble writing a y today. This is the hypotenuse, and this is the adjacent side. How could I make that ratio be 6? Well, there's actually a lot of ways I could do that, right? But one obvious way, well, maybe it's not super obvious, but one fairly nice way at least, is to put a 6 on the hypotenuse and a 1 on the adjacent side. And now this ratio is, in fact, 6 to 1. So we do, in fact, have the secant here for this triangle and this angle being 6. Okay, so this is the triangle that we want. Now, we want to find the sine of this angle theta. And what is the sine? Well, sine is opposite over hypotenuse. So I need to know, what is this opposite side? Well, to find that, I can use the Pythagorean theorem. So I can say, if I call this side b, then I can say that 1 squared plus b squared equals 6 squared. That means that 1 plus b squared is equal to 36. So b squared equals 35, and that means that b is equal to plus or minus, let's see, the square root of 35. There's nothing we can do with the square root of 35 because it's just 5 times 7. It doesn't have any square divisors. And we want to take the positive option here, of course. So what we can say is that the sine here, I've kind of run out of room here, so I'm going to erase the top and start writing up here again. Hopefully you guys have notes from that. So we're going to have that the sine of theta is plus or minus square root of 35. Now I say plus or minus because this is not really necessarily the angle in question. This is possibly just a reference angle for it. So we now need to ask, what is the quadrant here? Well, the quadrant is in this case going to be quadrant 1 because we are looking for secant inverse of a positive number, and the secant inverse for positive numbers, that lands in quadrant 1. Since we're in quadrant 1, that means the sine is also positive, and we can take the positive root. Now, if we'd found that it was not in quadrant 1, so remember, secant is 1 over cosine, and so it has, it's defined, we said that that goes from 0 up to pi. So if this had been in quadrant 2, then sine would actually still be positive there, and we'd still get the positive answer. So in this case, it wouldn't actually matter. In some other cases, though, you do have to worry about which quadrant does this actually land in. This should look really similar to what we were doing with sines and cosines. We just built a triangle with the required properties. We put the reference angle here. I should strictly speaking say this is theta r. It's the reference angle for theta. It's not necessarily just theta itself. So I was a little bit sloppy there and just wrote a theta instead of a theta reference, and I apologize for that. It should have been the reference angle here. And then we find the dimensions of that triangle, use that to compute whatever trig function we're looking for, and then we use the quadrant information to decide if that answer should be positive or negative. It sounds complicated. The key thing here is practice, okay? Because it is a complicated process when you first start it. It's like a lot of things. You first start doing this, yeah, it seems really complicated. It seems like there's a lot to this. It turns out it's not actually so bad once you've practiced it a little bit, okay? Let's try doing another example of this kind of thing just to illustrate how this can go in a slightly different case. Let me suppose that I want to find the cosine of let's say cosecant inverse of -4/3. Okay, so what we are going to say here is that this is going to be some angle theta with cosecant theta equals -4/3. We also know that this means that theta is in quadrant 4. Because remember that cosecant, this is like the inverse sine function, and it goes from -π/2 to +π/2. If it's going to be negative, it has to be down in quadrant 4. If it's positive, it's going to be up in quadrant 1. And we also know that this means that for the reference angle, we have the cosecant of the reference angle being equal to 4/3. Because the reference angle always sits in quadrant 1, and in quadrant 1, all the trig functions are positive. So I want to build a triangle with a reference angle, and the cosecant should be 4/3. Now, I want you guys to pause this, take a minute, see if you can build a triangle like that. Here's a hint in case you weren't able to get it. Remember that cosecant, this is going to be the reciprocal of sine. Sine is opposite over hypotenuse, so this is hypotenuse over opposite. So see if you can build a triangle where the hypotenuse over the opposite for this theta r, the reference angle, is 4/3. Okay, hopefully we're able to figure it out. I would put a 4 on the hypotenuse and a 3 on the opposite side. And now I just want to find what is the cosine of this angle here. So the thing that I want to do is I want to find this side. Let's call that side A. Then by the Pythagorean theorem, we have a squared plus 3 squared equals 4 squared. This means a squared is equal to 16 minus 9 is 7. So we get a equals plus or minus square root 7. So what I know is that the cosine of theta r is going to be equal to square root of 7 divided by 4 because it's adjacent over hypotenuse. That means that the cosine of theta is plus or minus the square root of 7/4. Now, do I want to do positive or negative? Well, theta is in quadrant 4. So here's the question you want to ask yourself. Is cosine positive or is it negative in quadrant 4? Take a minute and think about that. Okay, so the answer is that cosine is positive in quadrant 4. And so we take the positive value here. So all of this is going very similarly to what we were doing when we were just talking about the inverse sine and the inverse cosine. We are still just building the triangle and then working through it this way. Now, I'm going to tell you again, this is not like stuff that you're going to necessarily grasp the first time you try to do it. And this is why you have to keep practicing. So this is why it's so important to make sure that you guys really are doing all of the problems in the homeworks and practicing this stuff yourselves. One more thing I want you guys to do. To save myself from the embarrassment of making really messy pictures here, I want you guys to take a look at the graphs of the inverse trig functions. These are in 8.1 and 8.2 of your book, I believe, and they give you nice, pretty graphs. Now, remember that to get a graph for an inverse function, you graph the function itself, you take the diagonal line, and you reflect the graph over that line. So it's actually not too difficult to do. It's just, you know me and my messy drawings. I'm going to take advantage of the fact that we're doing these in short video segments and things and just say, go look in your books for that sort of thing, since I can kind of do that more easily than we would in a classroom. You can also, I would also really strongly recommend, in fact, that you take a look at the videos that my math lab has on these topics and use those to kind of see some further examples and explanations of doing this kind of stuff. All right, so sorry that today has been in 2 parts. I will be putting up something else pretty soon.